It's a pleasure and an honor to speak to you. Your program will say that the speaker is Giampaolo Tardioli. He sends his regrets and apologizes for being unable to make this trip. So I get to do the talk instead. I consider measurement to be a proxy. That means it's a substitute to help you understand how well your system is going to work. It's not going to tell you exactly whether it will work or how it will work, and sometimes not as in terms of how well it will work. But it's the best we have for today. And of course, since we do measurement in Keysight, that's the subject of my conversation. If you just think of one scenario, using a smartphone in a stadium as a audience member, all of the American football stadiums in the United States have FR2. So let's assume this is an FR2 service in a football stadium. It's pretty simple. You get your smartphone out of your pocket and you use the apps and the high-speed service and the high-density, high-capacity service that has been installed, and it should work just fine. But if this is going to be tested, the system looks like this. That chamber is taller than I am, and so is the rack of test equipment. It emulates maybe 3 base stations from different angles, and the only thing this really does is evaluate one mobile device. Not the core, not the RAN, and not the client or the server that is behaving the way that you want it to. So it's just a representation, the proxy of overall performance. And the actual performance you see is not going to be the same. Now, we specify a lot in 3GPP for the sake of behavior and for testing. And if I just do a deep dive into the 38 series of specifications, 3GPP folks out there, anybody attend 3GPP? Oh, come on, don't be shy, raise your hands. There's a lot of work that goes into these specifications. The radio spec itself is over 90 documents. There's about 20 documents about test. That's it. But even this proxy is complicated. Now, 38.101 does not define how things are tested. And most of us are familiar with this. It's now in 5 parts, totaling 3,400 pages, and the cover file of the first part has a 24-page table of contents. This is complicated, but that's not test. Let's look at maybe the conformance test spec, 38.5 or 38.508-1, which is just for the UE, conformance testing. 1,674 pages, and the cover file, not just the first part of the document, it's one file by itself as a table of contents that's 32 pages long. This is just for conformance test of the user equipment. So it's not just a proxy, it's a complicated proxy, and some would say it's still not enough. Okay, so we don't test everything in 38.508. Fortunately, there is GCF that sets priorities on what should be tested, and you get a subset of all of how to validate just your UE, just in radio performance. Well, the GCF has over 16,000 5G NR UE test cases as of the end of 2023. I have not kept track, but this is a big number. It's a super complicated proxy for what we have to do. Well, how did we get here? How many out there worked on 1G? Bo, thank you. There's at least 2 of us in the room that worked on 1G, maybe a few others. So we spent a lot of time focusing on simple physical measurements, radio power, modulation, occupied bandwidth. As we moved to 2G, we moved to digital communications. And it got more complex, bit error rate, power versus time. And who can forget the arguments over voice codecs and voice quality in 2G, right? Lots of extra things we had to test. And as we moved to 3G, the error rate of the block became more important than the error rate of the bit. And the cell would behave differently. Who can forget the cell breathing in the CDMA situations? More measurements on antennas and MIMO. And as we moved to 4G, now we had a complicated scheduler. We had to make more measurements over the air, and we first started doing quality of service measurements, not just physics. And every time we moved to a next generation, we still had to make the measurements we did before. The simple measurements in physics, but now they're becoming more complex. And in 5G, we have moved to making measurements on security, on reliability, on latency, on energy, network power consumption. So for 6G, we could maybe expect measurements or validation driven by policy, because its use in society, in-time and on-time delivery of packets, service level adherence, and quality of experience. Because we've moved from mobile voice focused on physical behavior all the way to behavior that is impacting how we operate in society. So we're already doing some of this higher level testing, not just the physics, but the functionality. And just a couple of examples of that we are involved in are the non-terrestrial integrated network space. So now we have a UE that will talk to a local base station. It might talk to a generative base station that is on a HAPS or a LEO, and it might talk to a base station far away through a bent pipe. And all of that needs to be simulated in an end-to-end environment where we manage what that link looks like. And even this mock-up here, even this system that's used for testing, which could either test the G node B or test the UE, is complicated as it is. But now we have a much more complicated integrated link. And this is capabilities that have been put together in the last few years for the sake of that business. Another example is what we call E-plane measurements. So RAN, energy efficiency and savings. And we know that the RAN is where most of the energy in a network is consumed, maybe until we start doing large language models. This is a complicated picture, but to zoom in just a little bit, the types of measurements are simple, right? We're just measuring watts. But the scenarios are complicated. How will the system be used? When we're making power measurements? How can we optimize those? And does that optimization process work the way we expected it to? This is a system that we set up working with a couple of other companies as a first of its kind, and it turns out to be quite complex. I quote Tracy Van Brackle from AT&T, who said a couple of years ago, it is impossible to make a power consumption measurement on a network. Well, I consider that a challenge, and so we've continued down that approach. These are systems that are already in place, but what can we expect for 6G? I could talk about this all day, but it's warm in this room, and I don't want to put you all to sleep. But just 3 examples of what we're working on. End-to-end latency, quality of experience testing, and how we're going to approach validation with artificial intelligence. The first example is a research proposal that we have put in front of the National Science Foundation, working with Ericsson and working with Cornell University and some medical companies and 2 surgeons. And this is a way of validating, can we do remote robotic vascular intervention surgery across a distance? Now, when I first heard the proposal for this, I thought they were crazy, because getting approval from the regulatory bodies is very tough, and why don't we just put the doctor and the patient in the same room? Well, it turns out that in the US, there's about 1 million heart attacks or strokes every year, and about 80% of those result in either a permanent disablement or death. And it takes about 4 hours until you are disabled or there's a fatality. It has to be less than 4 hours before you get treatment. And most people who have these issues are further than 4 hours away from the right facility or the right medical expert. And robotic surgery constrained in the veins, in the vascular system, from a remote perspective is much more feasible. So we put this proposal in front of the National Science Foundation to work through this process, and very excited about it, a combination of wireline and wireless links. And during the course of doing this, there were 2 things I have never done in my 40-year career working in wireless. One was conversation with a heart surgeon for work, right? I haven't even had a conversation with a heart surgeon for personal reasons, fortunately. The second thing I did is have a conversation with somebody from the Food and Drug Administration in the United States. Those are the people who would be the regulatory body that would approve a procedure like this. Another thing I've never done before. In those discussions, I realized the importance of validation in the user environment and how much of a different language we speak in telecommunications than the language that is spoken in the vertical industries we serve. So validating these situations, measuring them, requires a different approach. The next one is quality of experience. This is a subjective thing. I know the ITU body does not like that term, but we spent some time in a European-funded project called Triangle, which has since evolved to a proposal that has been accepted by the ITUT in Study Group 12 for a testbed framework for mobile application, quality of service, and quality of experience evaluation. And you'll see that 3GPP is just starting to look into these kinds of measurements or these kinds of specifications. And I won't go through all the details. It's a long document here, but the idea is to measure what we can, measure it from a user-centric perspective, and then aggregate those for a session quality score, but then do further aggregation for different kinds of sessions, multiple realizations, multiple devices under tests, different applications, that kind of thing. This is a terribly difficult way to quantify the subjective, but it is a necessary step if we want to understand how well the users and the vertical businesses are going to experience what we do in telecoms and these applications. And the last example is artificial intelligence. It is, my colleague Balaji did a great talk yesterday on how we think about AI from a testing perspective. And I really liked Dr. Wentong's talk that he just did about an innovative way to approach AI in networks. So when you go from a human-designed deterministic model to an AI model, maybe validating the result would be done the same way. We can test the network like we do today and see if it works the way we expected it to. Does it work as well as we thought it would? Does it consume the same amount of energy or less? Is the throughput higher? Is the capacity higher? Is the bit error rates lower, or even the user experience, is that better? The challenge is that in the AI domain, the validation process becomes very different. And this is a very interesting lesson we've been learning over the past couple of years when we've been working in details on this. And first of all, is that training a machine language model or machine learning model is interlinked with validation so that the training process, the testing process, and the validation process of the model are almost impossible to separate from each other. We think about traditional design as a design step and a validation step, but these are very difficult to pull apart from each other, and we have to think about validating the model and training the model as part of the same step. Very different paradigm in terms of what we're going to do to measure what we create with a new AI-enabled system. Yesterday's presentation from Samsung discussed how difficult managing the data was. Both the data was vast, that was the term that was used. So data come from many different sources, trying to aggregate that data and use it. And then which data do you use? Is it corrupt? And how do you manage all of the data that comes in? We are asked on a regular basis if we can synthesize training data for AI systems. And yes, of course we can do that. But that other part of the Samsung presentation yesterday was the synthesized data and the real world data yield inconsistent results when you look at how a real system operates. Great example and a challenge for us to figure out what do we do to help the industry from a data perspective, measuring the adequacy of the data, generating enough, and ensuring that it will be appropriate for training. And then the last is test coverage. This is always a challenge. I talked about that earlier, 3,400 pages or 1,600 pages of conformance test in 3GPP. Does that have adequate coverage? Maybe. But the way we think about test coverage with conventional designs, and we all do this, we design something, we implement that. There are a number of things that we do not test because we know they will work by design. I've heard that term hundreds of times in my engineering career, and probably 80% of the time they were right. It's going to work by design. In an AI system, in an ML system that you have trained, there is not a guarantee that it will work by design. If you haven't used the right data, if you haven't used enough data, if you haven't used representative data, if you have used data that has not been randomized appropriately, it will create a blind spot in terms of the system performance, and if you do not have test that coverages that blind spot, you will miss it. And so it's a different approach to understand how to manage test coverage. These are new concepts for me. This old dog has had to learn some new tricks, but they're great challenges, and we're very excited to be part of this. So for conclusion, this is a reminder to everybody, we still have to make the fundamental measurements, but that proxy is taking on a different form. And for us, it's very exciting because to me, it's a bigger way to engage, work directly with people like heart surgeons and government agencies. We don't have all the answers, clearly I don't, but that's where collaboration comes in. And that's what we're excited to do, is work together with everybody here. And that's why it's great to collaborate with the leaders in the industry. And so getting started on that is, well, a lot of it's actually underway. So appreciate the opportunity for that. And thank you so much for listening to my talk. And that's my conclusion. Thank you so much.